Welcome to the Science of Everything, Unlocking the Mysteries of the Universe podcast. I'm your host, Dr. Michael Chang, and I am thrilled to embark on this journey through the wonders of the universe with all of you today. Get ready to dive deep into the realms of physics, chemistry, biology, and beyond as we uncover the mysteries that surround us. Let's explore the beauty and complexity of the world we live in together. Kicking things off, let's delve into quantum mechanics, often considered the backbone of modern physics. It's fascinating how it challenges our conventional understanding of reality, isn't it?
Absolutely, Michael. What blows my mind is the concept of superposition, the idea that particles can exist in multiple states at once until observed. It's like Schrödinger's cat being both alive and dead in the box, which sounds almost poetic.
And don't forget about entanglement. Two particles can become intertwined so that the state of one, no matter the distance, can instantaneously influence the state of the other. It's like the ultimate cosmic connection, defying the very notion of space and time as we know it.
Indeed, Emily. This quantum entanglement has led to breakthroughs in quantum computing and cryptography. It's as if we're on the cusp of a technological revolution powered by the principles of the quantum world.
Speaking of revolutions, let's talk about general relativity. Einstein changed the game by proposing that gravity is not a force, but the curvature of spacetime caused by mass. It's a concept that's both elegant and mind-boggling.
And the predictions of general relativity have been confirmed time and time again, from the bending of light by gravity to the discovery of gravitational waves. These waves are literally ripples in the fabric of spacetime, generated by cataclysmic events like black hole mergers.
Let's not forget the Big Bang Theory, the explosive start to our universe. It's fascinating to think that everything we see, from distant galaxies to the molecules that make up our bodies, originated from a singularity, an infinitely small point.
The evidence supporting the Big Bang is compelling, especially the cosmic microwave background radiation. It's like the afterglow of the creation of the universe, still detectable today, which is just astounding.
And then there's the mystery of dark matter and dark energy, which together make up about 95% of the universe. Yet we know so little about them. Dark matter's gravitational effects hint at its presence, but it's invisible to our current instruments.
It's like the universe's hidden scaffolding, shaping the large-scale structure of everything we observe, from galaxies to the vast cosmic web. And dark energy, this mysterious force accelerating the expansion of the universe, it's as if the universe has its own agenda, expanding faster and faster.
It's clear we're just scratching the surface. The more we learn, the more we realize how much we don't know. The universe is a beautiful mystery, beckoning us to uncover its secrets.
And with every discovery, we push the boundaries of human knowledge a little further. It's a testament to our curiosity and ingenuity. Innovations in technology and methodology allow us to observe the cosmos in ways our predecessors couldn't even dream of.
Absolutely, Emily. Consider the James Webb Space Telescope, with its unprecedented resolution and sensitivity. It's designed to look back over 13.5 billion years to see the first galaxies that formed after the Big Bang, giving us a glimpse into the early universe that we've never had before.
That's a game changer. It'll help us understand the formation of stars and planets and possibly answer some of our questions about the origins of life. It's akin to having a time machine that can view the dawn of the cosmos.
Speaking of origins, let's not overlook the role of particle physics in our quest to understand the universe. The Large Hadron Collider has been pivotal in confirming the existence of the Higgs boson, often called the God particle, which provides mass to other particles.
And with each of these monumental discoveries, we're not just answering old questions, we're uncovering new mysteries. It's a never-ending, exhilarating chase. Like, what else is out there waiting for us to discover? What other secrets does the universe hold?
Indeed, Sophia. It reminds us that science is not just about finding answers. It's about asking better questions. As we peel back the layers of the universe, our understanding evolves, and with it, the the questions we ask become more profound.
It's the beauty of scientific inquiry. Each discovery is a stepping stone, not just towards what we seek to understand, but towards learning how much more there is to explore. The universe is an intricate tapestry of mysteries, and with each strand we unravel, the more we appreciate its complexity and our place within it.
Speaking of appreciating our place in the cosmos, let's talk about the illustrations in some of our leading science books. They do more than just complement the text. They offer a window into the abstract, making the unfathomable somewhat graspable.
Absolutely, Sophia. For instance, the illustrations depicting the warping of space-time around massive objects like black holes serve not only to educate but to inspire. They transform esoteric equations and theories into visual narratives that everyone can relate to.
These visuals act as bridges between the hard data and the human imagination. Think about how the iconic Pillars of Creation image from the Hubble Space Telescope has captivated minds around the world. It's not just a picture, it's a storytelling device that brings the narrative of star formation down to Earth.
And it's those stories conveyed through images that often ignite the spark of curiosity in young minds. Who among us wasn't mesmerized by the illustrations of distant galaxies and nebulae in our science textbooks? They draw us into the scientific dialogue, making us part of the exploration process.
Right? And in doing so, they democratize science. By making complex concepts visually accessible, illustrations ensure that you don't need a PhD to engage with the mysteries of the universe. This visual access encourages a broader conversation that encompasses all levels of society.
It also speaks volumes about the role of art in science. While science seeks to understand the universe, art makes that understanding visceral, evoking an emotional response that words or equations alone might not elicit. It's a beautiful synergy that enriches our pursuit of knowledge.
Exactly, Emily. And let's not forget the role of digital technology in this synergy. Today, animations and simulations allow us to visualize processes and phenomena that are impossible to capture with traditional photography or illustration. This technology is revolutionizing the way we see and understand the universe.
That evolution in visualization technology is paralleled by our advancements in observational technology. Just as the James Webb Space Telescope will open new windows into the cosmos, digital visualization tools will enable us to interpret and share those discoveries in ever more engaging and accessible ways.
Michael, you've touched on a crucial point. The James Webb Space Telescope and similar technologies are expected to flood us with data of unprecedented detail. However, translating that sheer volume of data into something digestible and, more importantly, fascinating for the public is where the real challenge lies.
Indeed, Emily. And it's not just about simplifying complex data. It's about storytelling, using that data to tell compelling stories about our universe. When people hear about a discovery, they want to know the story behind it. How was it made? What does it mean for us? This is where those interactive elements you mentioned, like quizzes and experiments, can play a significant role.
Absolutely, Sophia. Interactive elements can transform passive readers into active participants. Imagine integrating virtual reality experiences where readers can walk through the cosmic web or visit exoplanets. These aren't just educational tools, they're gateways to experiential learning that can heighten understanding and retention.
And let's not overlook the potential of gamification. Incorporating game elements into educational content can significantly boost engagement. People love challenges, rewards, and the sense of achievement that comes with solving puzzles or completing quizzes.
That's a fascinating point, Emily. It could fundamentally change the way we educate. Instead of rote learning, we could foster an environment of discovery and exploration. Imagine students embarking on virtual space missions to apply their knowledge of physics and astronomy in real-time scenarios.
It's an exciting future to consider, but we also need to be aware of the digital divide. As we move towards more technologically advanced educational tools, ensuring equitable access will be paramount. Otherwise, we risk widening the gap between those with access to these resources and those without.
Absolutely, Michael. The democratization of science education requires not just innovation in how we present information, but also in ensuring it's accessible to everyone, regardless of their socioeconomic status. Bridging that gap is crucial for the next generation of scientists, explorers, and curious minds.
This discussion underscores the multifaceted approach needed to engage the public, especially the youth, in science. We need the facts, yes, but we also need the context, the storytelling, and the interactive, accessible platforms that can transform curiosity into knowledge and perhaps into a lifelong passion for the cosmos.
Speaking of engaging the public and the youth, I think we also need to consider the role social media plays in disseminating scientific knowledge. Platforms like Twitter, Instagram, and TikTok have become important places for scientists to share their work and interact with a broader audience.
That's an excellent point, Michael. Social media does indeed offer a unique opportunity for scientists to humanize their work and make it relatable. By breaking down their research into digestible content, scientists can foster a community of engaged and informed followers.
Moreover, social media allows for the rapid spread of information, which can be particularly beneficial in the context of new discoveries. However, this also comes with the responsibility to ensure the accuracy of the information being shared, as misinformation can easily be propagated as well.
Absolutely, Sophia. The scientific community must navigate the fine line between making science accessible and maintaining the rigor and accuracy of scientific data. It's about finding the right balance to both educate and inspire without oversimplifying the complexities of our universe.
This balance could perhaps be struck by collaborating with science communicators and educators who specialize in translating complex concepts into engaging narratives. By working together, scientists and communicators can leverage each other's strengths to amplify their impact.
And let's not forget the importance of visual storytelling. Infographics, animations, and video content can often convey complex ideas more effectively than text alone. These visual tools can help to illuminate abstract concepts in vivid and memorable ways.
That's true, Sophia. For example, animations showing the expansion of the universe or the collision of galaxies can provide a visceral understanding that words alone might not. This kind of content can make the wonders of the universe feel more real and tangible to the public.
It also speaks to the importance of interdisciplinary collaboration in the sciences. Artists, writers, and educators bring perspectives and skills that, when combined with scientific expertise, can significantly enhance public engagement and education.
Indeed, Emily, the future of science education and public engagement is interdisciplinary and interactive. Embracing diverse skills and mediums will be key to unlocking the mysteries of the universe for a wider audience, making the science of everything not just understood, but truly felt and experienced.
This concept of interdisciplinary collaboration could revolutionize not just public engagement, but also the way we conduct research. For instance, utilizing virtual reality to simulate cosmic events could offer unprecedented insights into the workings of the universe, much like it enhances learning for students.
Absolutely, Michael. Virtual reality and other immersive technologies have the potential to transform abstract scientific concepts into experiential knowledge. This could not only aid in research, but also in sparking curiosity and enthusiasm for science in the general public.
Speaking of sparking curiosity, there's been a noticeable increase in citizen science projects which invite the public to contribute to actual research. This is a brilliant way of making science truly accessible and engaging by allowing people to be part of the discovery process.
Citizen science indeed represents a unique blend of public engagement and scientific research. Projects like these not only democratize science, making it more accessible, but also provide researchers with vast amounts of data that would be otherwise hard to collect.
And let's not overlook the educational aspect. Participating in these projects provides hands-on experience with scientific methods, furthering both knowledge and appreciation of the scientific process. It's a genuine win-win situation for both scientists and the community.
It's fascinating how technology and social engagement are reshaping the landscape of science education and research. It emphasizes the notion that science isn't just for scientists. It's a global endeavor that everyone can participate in and contribute to.
Right, Sophia. The democratization of science through these platforms could lead to unprecedented collaboration and innovation. By breaking down the barriers between the scientific community and the public, we're likely to see a surge in interest and investment in science.
And with this surge in interest, we must also consider the ethical implications and responsibilities. As we invite more people into the fold of scientific research, maintaining integrity and accuracy becomes even more crucial.
That's a very good point, Emily. The ethical considerations are indeed paramount. As we open up science to wider participation, we must ensure that the enthusiasm for contribution doesn't compromise the rigor and validity of the scientific method.
Absolutely, Sophia. The challenge, then, is to develop frameworks that balance open participation with the maintenance of high scientific standards. It's about creating an environment where citizen scientists are trained or guided enough to contribute effectively.
Precisely, Michael. This brings to light the importance of education and awareness. By educating the public not just on scientific facts, but also on the process of scientific inquiry, we can build a community of well-informed citizens capable of contributing valuable data.
And let's not forget the role of technology in facilitating this. Advances in data analysis, for example, can help us sift through the large volumes of data generated by citizen science projects, ensuring that the contributions are meaningful and scientifically valid.
It's fascinating to consider the future possibilities. Imagine combining the power of artificial intelligence with the collective intelligence of citizen scientists. We could accelerate discoveries in fields ranging from astrophysics to zoology.
Indeed, the potential is limitless. But as we embrace these possibilities, we must also be vigilant about the challenges, particularly in ensuring that the technologies we employ are inclusive and accessible to all, not just the technologically savvy.
That inclusivity extends beyond technology to also encompass diversity in our scientific communities. A diverse group of contributors can provide a range of perspectives that might highlight overlooked areas of research or innovative solutions to long-standing problems.
Diversity indeed enriches science. And in this era of global science, we're seeing the emergence of international collaborations that were once deemed impossible. This not only accelerates the pace of discovery, but also fosters a greater sense of unity in the pursuit of knowledge.
I think this unity you speak of, Michael, is key. It's about breaking down barriers, not just among countries, but within our own communities, bringing together people from different walks of life, with different experiences and expertise, to contribute to a collective goal.
Absolutely, Emily. And this is where storytelling and communication become vital. By sharing the stories of scientific discovery, the process, the setbacks, and the triumphs, we make science more relatable and inspiring to a broader audience.
Right, Sophia. It's about demystifying science, showing that it's not just the realm of the few, but accessible to many. By doing so, we not only inspire future generations of scientists, but also foster a more scientifically literate society.
And fostering scientific literacy is crucial, especially in an era dominated by misinformation. Educating the public on how to critically evaluate scientific information empowers individuals to make informed decisions, which is beneficial to society as a whole.
This brings us full circle to the importance of ethical considerations. As we endeavor to make science more accessible and foster broader participation, let's always strive to ensure that the integrity of the scientific process remains intact.
Indeed, the balance between accessibility and integrity is delicate but necessary. As we look to the future, let's be guided by the principles of inclusivity, diversity, and ethical responsibility, ensuring that the science of everything continues to unravel the mysteries of the universe for all.
Thank you, Michael and Sophia, for such an enlightening discussion, and thank you to all of our listeners for joining us on this journey through the science of everything. Remember, every question you ask, every curiosity you explore, brings us closer to unlocking the mysteries of the universe. Until next time, keep looking up and keep asking why.
Goodbye, everyone. Keep the spirit of discovery alive.
Farewell, and remember, the universe is vast and full of wonders waiting to be explored.